This is topic 8.1, Human Population Dynamics. We're going to talk today about reasons why population of countries and the world is changing, and we'll also talk about how to model and analyze it. What I have in front of you right now is a picture of the world. It's a population of 7 billion. Actually, this picture is a little bit old. Population today is more about 8 billion. Anyway, the countries that are drawn here are sized according to their population. And you can see some are kind of skewed. So if we look over here in the green, China is the most populous country in the world, followed closely by India. India will soon actually be the most populous country in the world. United States actually is the third most populous country in the world. We have about 336 million people right now. And surprisingly, number 4 is way over here in Southeast Asia. It's Indonesia. But what I really want to show you is how some countries are changing in population. Some are a little bigger and a little smaller than others. Africa in general kind of has a dilated look to it. So we'll talk about why countries are changing. There's two different ways we could think about population change. One is how many people are being born and how many are dying, crude birth rate or just birth rate. Now, numbers are typically listed in catalogs in terms of 1,000. So if it says United States, for example, is 12 births, obviously it's not 12. What they really mean is for every 1,000 people in the United States, we have a birth rate of 12. You can go ahead and do the division here. You divide by 1,000 and then multiply by 100 to convert it over to a percentage. That gives you 1.2. Or for those of us who know that when you divide by 1,000 and multiply by 100, it's really the same as dividing by 10. So whatever number you get, just divide by 10, and that gives you the birth rate in terms of percentage. So the United States is about 1.2 birth rate. This kind of shows you countries. You can see that we're one of the lower birth rates, Northern Europe. And if the question came up on an IB ESS test, analyze trends in this this picture, you would say that looks like Northern Hemisphere is lower birth rates, Southern is higher. In particular, most of the higher birth rates seem to be associated with Middle East or Asia Minor and Africa, particularly Africa. You could also say countries along the equator seem to have the highest birth rates here. Why do those countries have high birth rates? Well, it has to do with economics. Surprisingly, the lower the economy, that is LEDCs, tend to have higher birth rates. Poorer countries, interesting. You would kind of think it's the opposite. MEDCs have higher ecological footprints, but it isn't because we're having more people. It's simply because fewer people are grabbing up more commodities, so that's why our ecological footprint is higher. Education levels. People with more education tend to have smaller families. Birth control, obviously. Politics, such as China's one-child policy, although I think they've discontinued that now since their birth rate decreased a little bit more than they wanted it to. And in general, agricultural societies tend to have more children. You simply historically need a lot of children to work the farm and the fields. And I'm sorry to say this, farmers probably thought many of the children would die, wouldn't live to adulthood, so they had larger families. The opposite of birth rate, of course, is death rate, crude death rate. You calculate it exactly the same way, in terms of 1,000. And for the United States, so we have 9 deaths, so if we just wanted to divide by 10, very easy, we'd have a crude death rate of about 0.9%. Why do different countries have different mortality rates? Well, some countries have longevity. For example, Japan. I believe in Japan, Okinawa has the highest number of people over 100. Social class. Higher classes tend to do better. Occupations. Some occupations are hazardous. Urban versus rural divide. And I suppose I probably should have put down here medical facilities. In particular, infant mortality rates are decreased by good medical facilities and healthcare. Put them both together, birth rate and death rate, and you get the natural increase rate. Essentially, that means how much is the population growing. So for our numbers here for the United States, we had 0.3 because 1.2 minus 0.9, or we could have said 12 minus 9 and then divide it by 10. We'd get a increase rate of 0.3. That's not a great increase rate. That's pretty small. It's been decreasing lately. The United States used to have a much larger population rate, NIR, but we've decreased. Europe also has been decreasing. We can then figure out, based on a 0.3% NIR, how long it will take for the United States to double in population. The simple way is the rule of 70. You simply take 70 and then divide it by the NIR. So if we have 70 divided by 0.3, I think I did the math somewhere and it came out to be about 233 years. We'd expect at that rate, which will not be constant though, that's how long it would take for the United States to double in population. A more complicated way is you could use the exponential equation. You probably use these in your math classes. The population at any given moment is equal to what the starting population is times 1 plus the rate. The reason it's 1 is that you don't lose the population, you're going to add it to it. And then to the power of n, where n equals how many years are going on here. So for example, population of the United States today in 2023 is 336. We'd put that in our start. What will it be, for example, in 7 years? So n equals 7. If the rate is 0.05, I know I said before 0.3. Another textbook I just read said 0.5. Now, the interesting thing is most people get this mixed up. What do we put in the rate? Well, we don't put 0.5 in there. So if you remember, when you convert a number to a percentage, you are actually dividing by 100. So if I have 0.5%, what number actually was that? That really is 0.005. Let's just go through it really fast so you can remember. If I said 50%, we'd say the number was 0.5. If I said 10%, we'd say it's 0.1. If I said 1%, we'd say that's 0.01. So 0.5 is 0.005. And we put the 1 in here because we don't lose the 336 million. We add to it. So if we multiply and take the exponent here, we get 348 people. That pretty much makes sense. Hey, let's look at what's going on in the world right now. You can see that the world industrial revolution hit. Population started to increase. Certainly as farming techniques increased, we had more food. And then we get exponential growth here. And then you can see after about 1987, it's starting to curve down. So the NIR is going down here. And most biologists think that'll continue, and it actually will level off, surprisingly. So if we have 8 billion people right now, at the end of the century, 2100, we expect it to level off with the NIR as 0 at 11 billion people. And most biologists think we have plenty of resources to take care of 11 billion people. Now, we're going to go ahead and model these changes that I've just discussed. And we're going to do it in what we call pyramids, demographic pyramids. These will show us how human population is growing. There's many things you can look at in here, but the 3 most important things I'd like you to look at is, first of all, how wide is the base? That tells us how high the birth rate is going to be. We want to look at the slopes. The steeper the slopes means a large death rate, concave slopes. If they're straight or near straight, vertical, that's a low death rate. And the last thing is we want to look at any bulges in the pyramid. Those are abnormalities. And it probably told us that there was, a baby boom, or maybe there was a war or disease, a pandemic, something that may have changed the normal curve of the pyramid. Let's take a look at a pyramid and see if we can analyze this one. This one I put here is Swaziland in the south of Africa. You can see that it has a very, very large, wide base. That indicates not only are there a lot of children, but there's a very high birth rate. That's why there's a lot of children. You can also see that it's pretty steep concave here, which indicates that we have a high death rate. It looks to me like the female population is maybe slightly, about the same, maybe in some places a little bigger. We're very interested in that because obviously the number of young females, women have children, men don't. That'll tell us how the birth rate is going to change. And the last thing we want to look at here is what is the elderly population? Looks pretty small. And I don't really see any bulges here either. So that's my analysis of the pyramid. Let's compare this to what the pyramid is for the United States. Wow, this is really different. It doesn't even look like a pyramid, does it? A fairly narrow base that indicates a decreasing birth rate. Fairly vertical sides that indicates a low death rate. Looks to me like the population of female to males is about the same here. And I do see actually a couple of bulges. That one looks like it's bulging out a little bit. Maybe this is bulging out a little bit right here also, right? Should be going down, right? This bulge right here, by the way, is me. That's the baby boom that happened in the late 50s, early 60s, and so forth after World War II. A lot of children in the United States, economic conditions increased. So that's kind of me right over there. So very, very different between Swaziland and the United States. Hey, here's a question for you. How about Japan? Boy, this doesn't look like a pyramid at all, does it? Well, let's analyze it. Narrow base indicates a very, very low birth rate. Not only is it not steep and not vertical, it looks like it's bulging out here. So I would say that not only do they have a extremely low death rate, that's why the adult or senior citizen population of the country is so high, but they also had economic changes. This is probably the post-World War II boom. After the war, Japan had an economic revolution. Conditions got very good, probably a lot of children being born. And it looks to me like as you get into the older population, you have a higher percentage of females, certainly over here. So if you look at the pyramids, you can sort of see that there will be 5 different pyramids. We break those up into what we call the 5 stages demographic transition model here. You can't cleanly say which is which, but sometimes they're between 1 and 2, sometimes 2 and 3, but we'll just use this model here. We have 3 different things to look at in the model. The blue line here is the birth rate. The red line is the death rate, and the green tells us how the population is changing. So Swaziland and is probably over here in 1, maybe 1 or 2, shall we say. As the birth rate is equal to the death rate, you wouldn't see a change in population. As countries get a little more advanced, better medical facilities, they take care of infants better, the death rate goes down. This then means if the birth rate is still high, you would have a lot of children replacing the population. Population goes up. So that accounts for the wide base. As countries get a little more advanced, we're going from LEDC here to MEDC. Death rate continues to go down, but now the birth rate is going down. We're having a little more family planning, better education, and so forth. And so what's happening is that the NIR still keeps going up, but now it's starting to level off a little bit. And then we're probably somewhere up here on the top of stage 3, maybe the beginning of stage 4. And then we're starting to get to a 0 change in NIR again. This one had a 0 change, but for totally different reasons. Here we had no population change because both the birth rate and the death rate were high. Here we're having no population change because both the birth rate and the death rate are low. And that's kind of where we're going. So we're like down at a 0.3%. Maybe we're somewhere at the end of stage 4. And then we get way over stage 5 here, and the population now is actually decreasing. And the reason is that the birth rate stays low, but as people get older and older, they simply start dying. So you have a larger elderly population. This is what's happening in Japan, and it's starting to happen actually in Europe right now. So you can then compare the models with the transitionary stages. So I said Swaziland was like this, very large base, steep slopes. Very steep slopes here, but not quite as large. This is Brazil, maybe stage 3. United States, maybe we're stage 4. Heading towards stage 5. And Japan, which we saw has a negative birth rate, is actually NIR negative, is actually decreasing in population.